Hello. Today I will be doing the Chapter 3 Checkpoint 2 for 3.3 to 3.5 in pre-calc. So, the first question is log base 2.6, 8. So, I know how to solve this, but I don't know why you solve it this way, so just figure it out. So, you're going to take log base 10, because that's just the original thing, to the 8th, or times 8, divided by log base 10 times 2.6. You'll plug it into your calculator. Mine's broken, so it gives me just the whole number, but yours should say 2.17. So that's the answer, and you'll plug it in. Next, we have expanding logs. And there are a bunch of rules for logarithms, like there's rules for adding them, subtracting them, multiplying them, dividing them. So this is for dividing them. It's log base x over y, which is what we have division, equals log base a times x minus log base a times y. So what we have here is log base 5, x over 2, x to the second power over y to the second power, z to the third power. So we're going to plug this in we're going to do log base 5 times x squared minus log base 5 times y squared times z cubed. And this is as far as I got, so I'll get back to you guys when I have this all figured out. Okay, this is future me an hour later. I finished the checkpoint and I never went back to number 2 because there's no freaking numbers, so I don't know how the F I'm supposed to do this if there's no numbers, because you're supposed to expand it. But whatever. So just we're gonna just move on to problem 3. Alright, so for problem number 3, we are asked to condense natural log x minus 4, natural log x plus 2, plus natural log x minus 2. So it's a little bit harder with natural log, but we are lucky because natural log equals log base e. So we can rewrite all of this as log base e, which is basically just 10 in this situation, x minus 4, bracket, log base e x plus 2 plus log base e x minus 2, parentheses, bracket. Now, the sum of two logarithms of the same base is equal to the logarithm of the product of the arguments. So, what we have here, this is going to turn into log base e, you don't really have to write that though, x minus 4, parentheses, times log, double parentheses, x plus 2, parentheses, x minus 2. You see why we did that? It's because this equation and this equation, log base e x plus 2 and log base e x minus 2, it's the same thing because they have the same log. So now we're going to apply the formula a log base b times x equals log base b x to the power of a. So in this case, a is going to equal log x minus 4, b is going to equal 10, and x is x plus 2 times x minus 2. So what we're going to get here is log triple parentheses x plus 2 x minus 2 parentheses to the power of log parentheses x minus 4 parentheses big parentheses. So that is your final answer for question number 3. Now for question number 4, by the way, I'm 100% sure that all of this is wrong, but at least I'm getting it done, right? So we have solve the exponential equation algebraically, approximate the result to 3 decimal places. So you're probably asking me, where are you getting this information? And yes, you're right. I am taking this straight from the notes that I took when I was paying 100% 100% attention. So on my solving exponential equations, this is 3.4 day 1, okay? We get we get 4 examples, A, B, C, D. A is e to the, you know what, I'll just show you guys. What I have here is my note sheet, as you can tell. The information that I'm getting this from is straight from example number B. So we are dividing here. And the reason that I got this is because it has the number to the base to the power equals a whole number. And that is exactly what we have here. We have 1,000 to the e base to -4 to the x equals 75. So the first thing that I did here was I divided this all by 1,000 to get this power up here alone. Then we come out to -4x equals 0.075. Well, how do we get this x alone? You might ask. So glad you asked that. We're going to take the log of this. And what happens here is we get log base -4 parentheses -4x equals log base -4 times 0.075. This is similar to what we did in the first problem, evaluating. Now, the log -4 and -4x are going to cancel out because they're essentially the same thing. Why? I have no clue. So from that, we're left with x equals, because we're solving x equals log -4, because that's what's on this side over here, 0.075. Then, what do? You ask. We do exactly what we did up here. We take log base 10 times 0.075 divided by log base 10, 4. Now, I don't really know what happened here, but apparently I'm supposed to remove the negative on the 4 because when I type -4 into my calculator, it gives me a error. So I just took it out. It's probably wrong, but when I plug this all into my calculator, I get -1.868. It says approximate the result to 3 decimal places. It's -1.8684. So, of course, you round down. So it stays 8. Now, this next problem is I had a lot of trouble on, so I'm going to research for a little bit and come back to you guys with an answer. Alright, I figured it out. It's most likely wrong, but I watched a very helpful video. So, we're going to use the same equation, log A minus log B equals log A times A over B. So in that, we're going to get log 4 times x over x minus 1, because it's log 4x and log 4x minus 1, equals 1/2. Then, you're going to do this weird thing where you're going to take 4 and turn that half into the power. So what we're going to do is we're going to get 4 to the power of 1/2 equals x over x minus 1. Then, of course, 4 is the same as 4 over 1, and then we're going to cross multiply. So, x times 1 is x. 4 to the power of 1/2 is 2 times x minus 1. That gives us 2x minus 2, because you're taking 4 to the half power, that's 2, times x, so 2x, minus 1, 2 times -1 is, 2 times -1, yes, that is 2, that's correct. Then we're going to just do some simple stuff. So we're going to subtract x, which is going to get us, we're going to subtract x, and then we're going to add 2. So that's going to give us 2 equals 2x minus x, that's just x, and then -2 plus +2 is just nothing. So we get the answer 2 equals x, and that is the answer to question number 5. Alright, so problem 6. The value V in millions of dollars of a famous painting can be modeled by the equation V equals 10 base e to the power of k times t. T represents the year, and t equals 0 corresponds to 1990. In 2004, the same painting was sold for $65 million. Find the value k and use this result to predict the value of the painting in 2010. So, t equals 0 is 1990. So to get to 2004, we take 2004 minus 1990, which is 14. So t equals 14 represents 2004. And if you add 6 to that, you'll get 2010. So t equals 20 represents 2010. So the value is 65. So we do 65 equals 10 base e times k to 14. Then we take 6.5 because we're taking the 10 out, and we get 6.5 equals e to the 14 times k. Then we take natural log. This is just one of the rules of natural logs and everything, logarithmic equations. We take natural log 6.5 over 14 equals 14k. Of course, k is the value, over 14, because we're trying to find the value of k. So it will be natural log 6.5 equals 14k. And what do we do to get k alone? Because that's what we're trying to find. We're trying to find the value. So we'll divide by 14. If you plug this into your calculator, you will get 0.1337. That is around the value of k. So we need to find the value of the painting in 2010. So what we're going to do is take that same equation, and we're going to do v, that's the unknown value, equals 10 base e to the power of 0.1337, what we just did, times 20, which is the value, that is 2010. So we plug all this into our calculator, and we get v equals 144.978. So we're just going to round that up, and we're going to get $145 million to predict the value of the painting in 2010. All right, we've made it to the last problem. Woohoo! So this problem states, the speed of the wind s in miles per hour near the center of a tornado and the distance d in miles the tornado travels are related by the model s equals 93 log d plus 65. On March 18, 1925, a large tornado struck portions of Missouri, Illinois, and Indiana with a wind speed at the center of about 283 miles per hour. Approximate the distance traveled by the tornado. So, we're trying to find d here, alright? So, we got the basic setup equation of 283 equals 93 log d plus 65, because the speed is 283 miles per hour. Then, we're just going to do some classic math here. We're going to subtract 65. And we're going to get 218 equals 93 log d. Okay? Then we're going to use the power rule, okay? And we're going to take that and we're going to make it 218 equals log d of 93. How I know that? I don't know. I just know that's what we're supposed to do. Then we're going to take 218 equals log base 10, which is the normal base, d of 93. Then we're going to do basically what we did back in this problem, which was make it the natural log, blah, 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 blah. And we're going to take this base 10 and we're going to make it a whole number here. So 10 to the power of 218 equals d to the power 93rd power. Then, oh god, we are going to, I'm going to be honest guys, I'm taking all this information from Quizlet, but apparently we're going to square root this to 93rd square root equals d. Can I even put this into my calculator? Yes, I can. It is the shift x to the power. So, 93rd power, 10 to the 218th power. Well, we're getting a math error. However, on Quizlet it says that d is about 220.844 miles per hour. And we can just, I don't know, it doesn't really say if you need to round it to a certain decimal, so I'm just going to round up to around 221 miles per hour. And there we go! You've completed your Chapter 3 Checkpoint 2 for 3.3 to 3.5. partially incorrectly, but it's graded on completion, so you're fine. Yep, bye!